Okay, now let us take a look at question 3, which is on function. And the first part is just one mark, says give a reason why f does not have an inverse. Now let's take a look at function f. Now if we have this equation, and at first glance you may wonder why is the domain missing. Now if you see a function question whereby there's no special mention of the domain, it will be assumed that it is the largest possible domain, which is the set of all real numbers. Now, how do we show that f does not have an inverse? Now, recall test inverse is the same as test for one function. And how do we do that? We use the horizontal line test. Now, the question already told you that we do not have an inverse. So what are we expecting in our answer? Is to really demonstrate that f is not 1, 1, therefore no inverse. Means you must really demonstrate the horizontal line test. Avoid giving the examiner very generic answer whereby everyone can just memorize saying, oh, it's not 1, 1, full stop. Okay, these are not good enough. So to demonstrate the horizontal line test, the best is just draw the graph. So we draw the graph of this equation. Okay, so you can use G2 to help you if you really don't even know. And the turning point would be 2, 4. So we can say by drawing a horizontal line, say y equals to 1, it cuts the graph of f at more than 1 point. That's why f is not 1, 1. That's why inverse doesn't exist. Okay, so let me write on the next slide. Since the line y equals to 1 cuts the graph of f at more than 1 point, f is not 1, 1, hence f inverse doesn't exist. Now the second part asks you, now instead of considering the entire x-axis as a domain, we are going to do some restriction. And what form of restriction do we want? We want to restrict the form x less than or equals to a. And we want to find the largest possible a such as f is 1, 1. So if we look back at the graph, this is a quadratic curve symmetry. You realize that if I take half of this quadratic curve, it will be 1, 1. If I extend it beyond this region, then the graph will not be 1, 1. So it is clear, that the region we want, now we want x less than or equals to a. So we want from negative infinity to a certain number. We want the largest a. So it should be this interval highlighted until here. And the x value at this point is 2. So the largest value of a is 2. So for the remaining part, you need to take note that now we are looking at the new domain for f, which is x less than or equals to 2. Now they tell you to, apology, this one shouldn't be a, this one is actually k, but it doesn't matter. Now the next one is asking you to define the inverse. So we need two things, domain of the inverse and the equation of the inverse. So let us find the equation of the inverse. Standard steps. Okay, let y equals to 4 minus x minus 2 square, and make it a good habit to write down. Now my x is less than or equals to 2. So what's the meaning of inverse? It means to interchange the rows between x and y. So now I have y as a subject. I want to do some algebraic manipulation. I want to switch the rows so that x should be the subject now. So it's just a pretty simple algebra. So I have x minus 2 squared equals to 4 minus y. Now this is where a lot of students make the mistake over and over again. I'm trying to find an expression for x in this something like quadratic equation. So I have something squared equals to 4 minus y. When I take so what is a solution? There are two possible solutions: 4 minus y or the negative version. It's just like solving x squared equals 4. You do not have 2 as the only answer. You should have plus minus 2. So we have two possible solutions, but remember, let me write here, x is 1, should be f is 1, 1. And my x is less than or equals to 2. So x should only have one equation to represent it, not two. So which one to reject? You check which equation will give you such x. My x will be less than or equals to 2. So we reject this one. State the reason: x less than or equals to 2. Therefore, we have the equation for the inverse already. It will be 2 minus square root 4 minus y. And the next thing we need is a domain of the inverse. Now, when we talk about function, we need two things: equation and domain. They are equally important. So how to find the domain of inverse? Recall, domain of inverse is the same as range of the original function. So what is the range of the original function? Go back to the graph. So you go back to the graph. Okay, let me choose another color. Now, we are only looking at this portion of the graph. X less than or equals to 2. And what's the range? The maximum point is 4. Okay, the lowest point is actually negative infinity. So my range of f, okay, is actually minus infinity until 4 including 4. So this is a complete solution you should have in finding f inverse. Now the next thing we want to talk about is about composite function between h and g. So we want to test whether hg exists. So let me write here, test if hg exists. So which one is my first function? Always read from the right hand side. This is my first function and this is the second function. So what's the condition for composite to exist? Range of the first function subset for the domain of the second function. So this is what you want to test. What is the range of g? Okay, we are given the equation, we are given the domain. So the best way to find range is to simply sketch a curve. So I only want from minus 1 to 2. So it should have something like this. Okay, note, this is in a completed square form, so the lowest point would be actually when x is equal to 1. Okay, so this coordinate, the turning point, the mean point, okay, would be 1, 3. And the highest point, if you look, the highest point is here, is coordinate minus 1, 7. So what is the range? The range would be from the lowest to the highest. So range of g is 3 to 7. Domain of h is given x greater than 0, so 0 to infinity. So we check, is this a subset of this? So we say, since range of G is a subset of domain of H, HG exists. And the last part is we want to find, think of the word exact range of HG. So again, my recommendation is to use graphical approach. So how to draw graph, we need two things, the equation of HG and the domain of HG. Now let's state the domain first. Domain of the composite is equal to the domain of the first function, which is -1 to 2. Next, the equation of Hg is the same as h bracket gx, which is 2 minus e power. I replace all my x with gx, so I have x minus 1 square plus 3. Okay, this graph is not easy to see through GC, but you should roughly know that it is through this shape. Now, we want to find the range, so you should ask yourself, between -1 to 2, what is the highest point? Take note, we are doing 2 minus an exponential term. So to get the highest point, means the largest value of the y, you should try to make this negative exponential term as small as possible. So the smallest value for this to make this exponential value as less negative as possible, we should try to make the power 0, and this will happen when x is equal to 1. So over here, the y value will be 2 minus e 0 square plus 3, so it's 2 minus e power 3. Now to get the most negative value, so you should think of how to make this exponential term as large as possible. So with the negative sign, you'll be very, very negative. So you ask yourself, between -1 to 2, which value of x will make this power as big as possible? So the answer is -1. So -1 I have -2 whole thing square. I will have e power 4 plus 3, which is e power 7. So from the graph, my range of Hg would be from 2 minus e power 7 to 2 minus e cubed.